We shall study the second part of the semiconductor electronics feedback amplifier and transistor oscillator as shown in figure 1a, b and c. Now the explanation is that in an oscillator we get an AC output without an external input signal. On other words, the output is an oscillator is self-sustained. Whereas an amplifier is taken, a portion of the output power is turned back to the input in phase with the starting power. This process is termed as positive feedback. We shown in figure 1a, the feedback can be achieved by inductive coupling through mutual inductance or LC or RC. Networks, different types of oscillators essentially use different methods of coupling the output to the input apart from the resonant circuit for the obtaining oscillation at a particular frequency. For understanding the oscillator action, we consider the circuit shown in figure 1b, in which the feedback is accomplished by inductive coupling from one coil winding T1 to another coil winding T2. Note that the coils T2 and T1 are wound on the same core and hence are inductively coupled through their mutual inductance. As in an amplifier, the base emitter junction is forward biased while the base collector junction is reverse biased. Suppose switch S1 is put on to supply power bias for the first time. A surge of collector current flows in the transistor. This current flows through coil T2 where terminals are numbered 3 and 4. This current increases from X to Y. The inductive coupling between coil T2 and coil T1 causes a current to flow in the emitter circuit. As a result of this positive feedback, the current increases from X dash to Y dash. The current in T2 connected to the collector circuit acquires the value by when the transistor becomes saturated. This means that maximum collector current is flowing and can increase no further since there is no further change in collector current. The magnetic field around T2 causes to grow. As soon as the field becomes steady, there will be no further feedback from T2 to T1. Without continued feedback, the emitter current begins to fall. Consequently, collector current decreases from Y towards Z. However, a decrease of collector current causes a magnetic field to decay around the coil T2. Thus, T1 is now seeing a decaying field in T2. This causes a further decrease in the emitter current till it reaches Z dash without the transistor is cut off. Therefore, this means that both IC and IE ceases to flow, so the transistor has reverted back to its original state. The whole process repeats itself, that is, the transistor is driven to saturation, then cut off, and then back to saturation. The time for change from saturation to cut off and back to determined by the constant of the tank circuit or tuned circuit. Inductance of coil T2 and C connected to the parallel to it. The resonant frequency nu per hour 1 by 2 pi root over LC at which the oscillator will oscillate. Now the different type of oscillator are tuned collector oscillator, tuned base oscillator, collector Colpitts oscillator, Hartley oscillator and RC oscillator.